Investigating alternate sequences. Sometimes sequences have terms that are alternate. In fact, the terms may actually alternate in sign. The steps to finding terms of the sequence are the same as if the signs did not alternate. However, the resulting terms will not show increase or decrease as n increases. Let's take a look at the following sequence: 2, -4, 6, -8. Notice the first term is greater than the second term, and the second term is less than the third term, and the third term is greater than the fourth term. This trend continues forever. Do not rearrange the terms in numerical order to interpret the sequence. Now, if we're given an explicit formula with alternating terms, we're going to write the first n terms of a sequence. Step number 1, we're going to substitute each value of n into the formula. We're going to begin with n is equal to 1 to find the first term, a subscript 1. The sign of the term is given by the following: -1 to the power of n in the explicit formula. To find the second term, a subscript 2, we're going to use n is equal to 2. And then we're going to continue in the same manner until you have identified all n terms. So for example number 2, writing the terms of an alternating sequence defined by an explicit formula. We want to write the first 5 terms of the sequence, where a subscript n is equal to -1 to the nth power times n squared over n plus 1. So in step number 1, we're going to substitute n is equal to 1 all the way through 5. So you can see here we list n is equal to 1, n is equal to 2, 3, 4, and then 5. And we're going to plug it into the formula a subscript n, which is equal to -1 to the nth power times n squared over n plus 1. So therefore all the n's are going to change to what we're going to set it equal to. So when n is equal to 1, we have a subscript 1, which is going to equal -1 to the first power times 1 to the first power over 1 plus 1. So let's do the order of operations. Well, -1 to the first power is -1, and -1 times 1 to the first power just gives you -1. In the denominator, 1 plus 1 is 2, so we end up with -1 over 2. And therefore, that is our first term of the sequence. When n is equal to 2, we have a subscript 2, which is going to equal -1 to the second power, and then 2 to the second power over 2 plus 1. So as you can see here, we're plugging in n to be the value of 2. So let's go ahead and highlight that. Okay, so the n here is 2. It's 2 here. It's 2 here. And R2 is here. Same thing with this 1. This is the one that replaced for n. This was n, and this was also n. So let's find the second term here. So -1 to the second power is +1, times 2 to the second power, which is 4 in the numerator, and 2 plus 1 in the denominator is going to give us 3, so it's 4/3. Okay, then we're going to have n is equal to 3. So now this becomes a subscript 3. We replace this exponent to be 3, replace this to be 3, and this also to be 3. So all the n's become 3 in the third term. So -1 to the third power is -1 times 3 squared, which is 9, so that's -9, over 3 plus 1, which is 4, so it's -9/4. Next we have n is equal to 4, so this becomes a subscript 4, which is the fourth term. Again, we're going to replace all the n's to be 4. -1 to the fourth power is +1, times 4 squared, which is 16, so we have 16 in the numerator. 4 plus 1 is 5, so it's 16 over 5 for the fourth term. And then the fifth term, we're replacing all the n's to be 5. So let's follow the order of operations. -1 to the fifth power is -1 times 5 squared, which is 25, so we have -25 over 5 plus 1, which is 6. So therefore, the first 5 terms of the sequence with braces are -1/2, 4/3, -9/4, 16/5, and -25 over 6. Now the graph of this function is going to be shown in figure 3. And now it looks different from the ones we have seen previously in this section because the terms of the sequence alternate between positive and negative signs. So you can see how it's going to look different because it's an alternating sequence.